Engine Performance 2, Test 5. Inductive amp meters work because of what principle? Inductive amp meters work. Engine Performance 2, Test 5. That's the one you should have. Everybody got the same. Everybody got the same test. There it is. Well, you got emissions test or something?
I have an emissions test.
Bad. All right. Who knows the answer to that? Well, no. We talked about voltage drop a lot, but it's actually C. A magnetic field surrounds anywhere carrying a current. A magnetic field surrounds anywhere.
What's the answer?
Yeah, that's C. A magnetic field surrounds anywhere carrying a current. A meter used to measure amps is called a what? That's a D, ammeter. Ammeter. They don't say amp meter, they call it ammeter. Now, voltmeter should be connected to the circuit being tested how? How should it be connected? In series? In parallel? Only when no power is flowing? Or both A and C?
Both A and C.
It's going to be B, in parallel. You can connect it when power is flowing. Now, an ohm meter should not be connected to a circuit when power is flowing. You know why? Because you won't get a good reading. That's why it's just the way it is. You got that? Everybody got that, right? All right, now let's look here at the next one here. Number 4, an ohm meter should be connected to the circuit being tested. A, with current flowing, wrong. B, when connected to the battery of the vehicle, power of the meter, wrong. C, only when no power is flowing. Only when no power is flowing. 5.
What is a high impedance meter?
High impedance meter is a meter that will not let any current flow. All right, and I'll tell you what I mean by that. If I take a meter, like a Simpson meter that I actually put in the bid sale that was over here, all right, that Simpson meter and meters that are not high impedance, that Simpson meter may not qualify like that, but like a test light, low impedance test light, if you take the test light and I hook it up to ground and I touch it to the ground, the side of this relay is supposed to trigger it, that test light bulb will flow enough current to click that relay.
Okay.
A high impedance test light or meter will not energize the relay. You can measure what's there, but you will not energize that relay. And a lot of these meters, even these cheapest test lights that you can buy at a parts house now, they're making them high impedance. And I don't like that, because when I'm checking relays and stuff, I like using my test light that will close that relay. See what I mean? I like that test light to carry a little current. And if a high impedance light, if I've got a circuit that has got a bad connection and won't carry a load, I can energize, and I can put my light to that thing, and that little low impedance light will light up. And it'll tell me, yeah, there's voltage here, but my high impedance light is going to burn the bulb dim, and it's going to tell me there's not enough current there.
Right.
See what I'm saying? So, a low impedance light, in most cases, automotive is more valuable than a high impedance light. And they're always terrified that you're going to, burn up the engine controller or something like that with a test light.
You did something stupid.
Yeah, everybody should know that you're not going to use a test light to measure your throttle position sensor voltage. That's just silly. Although I tell you what, I have seen people do that. And it didn't hurt the computer either. Just it would actually light it up a little bit. But anyway, one way or another, that's what the high impedance is. High impedance, the number 5, has high internal resistance. That's basically what that means. A meter that is set to DC reads on the 4-volt scale.
Okay.
The meter leads are collected to a 12-volt battery. What's it going to display?
12 volts?
It's on the 4-volt scale, remember? It's going to read OL. You ever seen that? Out of limits, or that's what that's supposed to stand for, I believe. Or I have heard other people call that overload instead of out of limits, whenever it reads like that. What could happen if the meter leads were connected to the positive and negative terminals of the battery while the meter and leads were set to read amps? It's going to blow the internal fuse. And ladies and gentlemen, if you're using one of those expensive fluke meters, you're going to have to buy an expensive fuse to go in it. $6-7 a pop for the fuses. And so if you use one of my little yellow ones and you blow the fuse in it, you can buy a pack of fuses at Radio Shack for $1 or something. But I mean, it'll still carry 10 amps is all it's going to carry. You see where I'm going with that? I mean, this one here will measure 10 amps. These little $10 meters will measure 10 amps. That Honda running all right?
Huh? It is.
Cool.
Smooth.
He did $1,000 worth of work on that car and only spent $100 doing it. Ain't that right?
600.
Do all that?
Yeah, pretty cool.
How you do
Timing belt, water pump on a Honda Civic 2002 model. Pretty big job. They looked it up on all data to see what the labor time would be and figured it up,
How long did it take you to do it?
They almost got it done that first day, and they polished it off the day of yesterday.
Oh, that ain't worth that.
But they needed a real cowboy to help them get the timing belt on there because there was some issues. You know how some of them timing belts feel like they're too short and won't quite go on there, and the man had to help them with that. So that's all right. I was trying to encourage them to get it, to do it so they could have it, but
What, it was one tooth off and y'all couldn't get it to go in?
no, it just wouldn't go on there. I mean, you know how some belts are a little too thick, and whenever they're thicker than their factory belt, by the time they go around that little tensioner, they won't quite fit on there unless you sort of work with them and all that. And you don't want to get really rough with them because you'll tear them and then they'll come apart and all that kind of stuff. But anyway, all's well that ends well. Okay, what would happen? Let's see. We blew the fuse, right? We're gonna blow the fuse or damage the meter. That's number 7. Remember how I said when Donnie was getting ready to check a circuit that he was afraid was going to damage the meter, and I did the bubble paper behind him, and he went, oh, because he thought he'd blown his meter up. All right. What the highest amount of resistance that can be read by the meter is set to the 2,000 ohm scale is what?
2,000 ohm?
I got so used to 2K being 2,000, I just rattled off 2,000 when I came to 2K. K is kilo for 1,000. All right. If a digital meter face shows 0.93 when it's set to kilo ohms, what's that mean?
93 ohms?
No.
130.
930 ohms. That's right. That's number 9. A reading of 432 shows on the face of a meter set to the millivolt scale. The reading means
0.432.
Yeah, 0.432. What is how much of a volt is 0.432? Huh? It's less than a half a volt, isn't it?
Almost half a volt.
Yeah.
About what you just thought.
Understand the decimals. You guys pretty good at math? Are you a math whiz?
Not really.
Maybe this all
I can do math.
Math is good. It is our friend. Okay, I asked these guys this other question the other day. You guys hush because you know the answer, okay? Except you might not. And engine stuff, right? So I'm going to start out by telling you a millimeter is equal to 40 thousandths of an inch. Remember that? A millimeter is equal to 40 thousandths of an inch. Now I picked up an engine part that came out of some foreign-made car, and it says the bearing is 25 hundredths of a millimeter, oversized. So how many thousandths of an inch is that? I gave you all the information you needed. It's not that hard. Tell them how it works.
All right, you said 1 millimeter equals 40,000.
Yeah.
And what was the?
25 hundredths of a millimeter. And I want to know how many thousandths of an inch that is. How many thousandths of an inch is 25 hundredths of a millimeter?
10.
10 thousandths. How do they know that quick? Because all you got to do is split the millimeter into 4 parts, right? Yeah. Because you already see if the 25 hundredths is a fourth of a millimeter, and I've already told you a fourth of a millimeter is 40,000. Now, what was really something was I asked a whole gaggle of high school kids that in here, and they were all deer.
It took them about 2 or 3 minutes.
Yeah, deer in the headlights all over the place, and most people can't answer that because if you're looking at them, they shut down. Well, Gene walked into the shop, didn't have no idea I was going to ask him that, had never heard it before, and I asked him that question, and I says, 40 thousandths of an inch, 1 millimeter, all right? And then I says, 25 hundredths of a millimeter is how many? 10 thousandths. Bam, just like that. I mean, because he's constantly working that stuff in his mind. Gene rolls numbers in his mind all the time. Ask him about the lights in the shop, and he'll tell you. Do you know how many lights how many volts these lights in the shop are running on? The ones in the ceiling? 277 volts. And he'll tell you exactly how he comes to that figure, and I'll just just spits it right out, you know. But if you're used to doing that stuff in your head, you'll be able to do it. But if you just say, I can't. One time I went to get some gas in Dothan years ago. With all due respect to this high school I'm about to mention, I'll call it ex-high school. You know, it's not Dothan High; it's a different one. And I go over there and I said, this kid was there behind the cash register. His cash register was down, and I gave him $1, and he owed me some change back, and he didn't know how to figure out change for $1. And I said, can't you do change for $1? Because you know your cash register usually does it for you, you know. But his cash register was down or something. And he goes, hey, give me a break. I went to such and such a high school. Huh? Like that was his excuse for not being able to even make change for $1 because he went to that particular high school. You see, I mean, it's a joke when the kid that went to the high school bears it as a badge of honor that now I don't know anything because I went to the high school. What's wrong with this picture? You see what I'm saying? Anyway, got to be able to make that happen. Okay, which of these is safe for use in circuits with electronic components? What are you going to look at? Number 11, A, an LED test light. Which device illuminates a different color when connected to power or ground side of the circuit?
Power probe.
Well, power probe, but that's not. Logic probe.
Oh, I thought that was.
You know what? Logic probe is wonderful for doing power window troubleshooting. Because you got this thing. This is how it works, guys. I got one here to show y'all. You get power. You get the battery, power and ground, and you carry this little thing. It's got a long cord on it, and it's got a light so you can see what you're doing. And it's got a little display telling you how many volts is there. And when you touch it to something, it'll burn green if it's ground or red if it's hot. That's cool, isn't it? Then you operate your power window switch back and forth, and it ought to swap from red to green. Then you move it to the other terminal, it'll swap from red to green. If you want to feed some power in there, you can work a little rocker switch. Or if you want to feed it ground in there, you can do that. And it's got a little circuit breaker in it. And it's got a little beeper, too. But it's cool. It costs $100. But a cord, I mean, you can plug an extension cord that it comes with, and you can reach from, that corner of the room way out yonder. I mean, it's real long. And here's another thing we can do. And we're doing electrical stuff. Let's take a 2x4 or some kind of little box that's got two pieces of wire sticking off of it, and use some of your speaker wire that you can wire up your stereo with, and have a big, long piece of speaker wire, and you can hook a, you need to fuse this, by the way. You need to put a fuse in the box. But you can hook one wire to positive, one wire to negative, have them marked, have a red and a black lead, and have plus and minus on your box. And have that long enough to where you can carry it anywhere on the car you want to go. So you've always got ground, you've always got power where you go. That handy or what? I seen these guys doing that. It was funny over there at the shop where I used to work. One guy had a 2x4 about that long, had 2 nails in it. And he had a piece of paper. Hey,
Sean.
Mr. Bradley, how are you doing there? All right. Anyway, he goes over there and he carried his power and ground 2x4 with him everywhere he went. Okay. Now then, which device may be useful for testing Hall effect sensors? Which device may be useful for testing and what is a Hall effect sensor? You remember? You guys remember Hall effect sensor, right?
Yes, I remember. Yes.
Somebody point to a Hall effect sensor.
Crank sensor.
All of them? That little old 2-wire crank sensor on that motor over there, it's a variable reluctance. It's not Hall effect. The Hall effect sensor is going to put out what kind of a signal? Square wave. And that variable.
Out there on that board.
Yeah, well, the one on the board doesn't put out a square wave. It's like that one there. The one on the board is the same kind of sensor as that. And we actually did one. This right here. This right here is a Hall effect sensor. This one right here. Remember that little thing? That little sensor right there puts out my distributor fell off of there. It's got a square wave. And what it does, I got to hold that up. I pull that out. That Hall effect sensor, and I need to make sure you understand that, there's a magnet right here with a little piece of metal that makes a loop. And whenever there's nothing interfering, this little piece of semiconductor material, actually it's got 3 wires going to it. It's got power, ground, and a signal wire. And every time these vanes whirl between there, you get an on and off switch. In other words, it doesn't just go up and down, it goes on and off. Now, the old kind of distributors we used to have years ago put out an analog signal, which was like camel humps and all that, or they had particular waveform shapes. But everybody needs to know, as soon as somebody says the word Hall effect sensor, you need to instantly know what they're talking about. It's a square wave generating sensor. And some of on this Dodge Caravan that y'all just worked on, It's got a 2-wire sensor that's a Hall effect sensor on the brakes. And there's a way you can check that. I actually wrote an article on my speed sensors article I wrote for Motor Age about how you can check it with a very simple meter. There's these other people that have this real expensive way and elaborate way of checking this kind of thing to make sure it works. And all you really got to do is there's got a 12-volt lead and it's got a ground lead. And you go into your 12-volt lead with a meter, and when you turn that wheel through, you're actually going to see that thing switching. You can hook a scope up to it and do the same thing. You don't even have to disconnect it. You just back probe it with a paper clip or something, and hook your, check between it and the ground. It'll go up and down, up and down, up and down. And that's something that is real cheap. Doesn't cost very much to do.
Low power test now?
Yeah, low power test light would probably. Well, basically, you got 12 volts there, and it's basically just switching a little bit. It's not going all the way down to nothing and all the way back up to 12. It's actually doing a square wave switch. It's like between 12 and 10 volts or something like that. The computer is looking at milliamps, 7 to 14 milliamps. Yeah, but basically a regular old voltmeter will do it if you just watch it, or whatever. You can do it with a meter. You just got to, and it'll know that the car is moving all the way down to almost a dead stop. Because on the other ones the amplitude decreases to where you just basically got a wavy line. Anyway, but that's what they started doing a long time ago. And you can't measure those by measuring the resistance with a meter, with an ohm meter either. It won't give you anything. Let's see. Let me see here. When using a digital multimeter, the black lead usually goes where? Common port. Kilohertz is a unit describing what property?
No, frequency.
All right. What's another word for frequency?
Hertz.
Wavelength.
Hertz.
Well, wavelength is not a bad thing. Frequency. I mean, he's right, but hertz is what we're talking about. Hertz is 1 hertz is 1 cycle per second. Kilohertz is 1,000 cycles per second. But that's your radio station. Your FM radio stations are in megahertz. Bouncing up and down there.
I thought you were looking for something outside the use of the word hertz.
Yeah, makes you think of a rental car, doesn't it? HERTZ is or HZ. All right. The rental car people, they don't. They frequently rent cars, so they name themselves Hertz. Okay, I guess. All right. So ammeter should be connected how? You connect an ammeter across the load?
Yes.
No, it's going to blow the ammeter if you do. Second rate amateur.
In series.
All right. In series, you're going to let the current flow through it. Unless it's an inductive ammeter, then you clamp it around the wire. Okay. To prevent blowing the meter fuse in a digital multimeter, what do? Never test the resistance of an unenergized circuit.
It's pretty simple.
Well, actually, that's the answer that they were wanting in here was install a fuse in line with the meter lead. But I will tell you that the meter lead, now you're going to do that if you're using a very expensive fluke meter, but the only time you're ever going to blow a fuse in a meter is typically when you're doing something you're not supposed to be doing, like using an ohmmeter to measure, current. Okay, in other words, if you take an amp meter and you put it on to measure amps, and you touch it to the hot in the ground side of a battery, and I've seen people do that, it pops the fuse in the meter every single time. Okay, one more time. Let's see what I hear. Let me see where I'm at. Which type of digital multimeter can measure current when clamped around a conductor? Inductive, that's right. The ability to measure AC current is useful when diagnosing what?
Alternator function.
Alternator function. He's pretty good. Listen to that.
I can look at.
Alternator function. Whenever you connect your scope directly to the wire coming out of the alternator, you're basically going to see, if the scope is set up right, you'll see a ripple pattern. Now, if the alternator has got bad stator or diodes in it or something like that, you're going to see ripple, ripple. That's what they say in the book. You're going to see something that looks like that. What I see when I've hooked them up like that is I see a ragged, ugly pattern. It's just all over the screen. That's what I've seen when I've hooked them up. It's awful. So if my charging system tester tells me that a diode or the stator is bad and an alternator, then I'm going to be following up with my scope to make sure. That's the long and short of that. All right. Yeah, let me see here. Okay, number 20. The internal resistance of any meter is effective only if the meter is set on the what scale? Everybody got that? Everybody like that? That's a C. There you go. When measuring resistance, a reading of OL means what? Again? You notice how we're beating a dead horse here? Yeah, either overload or out of limits. It means that you got to go up a range. When I'm measuring, incidentally, when I'm measuring something that's ohms, and I don't know what I don't know how much it's going to be. I start out on my lowest range on ohms. That's on ohms. And if it don't read anything, and you'll see these meters do this. If you're measuring up to something that's a greater amount of resistance than what the meter is set to, it will flash a reading up and then it'll go away. I don't know if you've ever seen it do that. And then you turn it up one range. You keep clicking up, and the lowest range that you can read that is the most accurate. Now, most of your meters nowadays that are really high-end meters, like the one I carry in my pickup truck, is a auto-ranging meters. And I don't really like those because a lot of the times I've seen professional mechanics that get confused about the reading. Because I want to select my range if I can, see? And you can do that even on an auto-ranging meter with a button, you know. All right. Let's see if we can do this, rest of this before everybody turns into a skeleton. Okay. When measuring resistance, OL means, okay, when interpreting meter readings in auto-ranging mode, number 22, that's A and B, yeah. Note the prefix indicated by the meter, convert the reading prefix to base units if needed in the end. Digital meters for automotive testing should include what?
C.
I mean, whenever you pick one, you know, if you're going to, especially if you don't spend some, A and B. DC amps, at least up to 10 amps. These little red meters we get out here, these heavy, the robust looking red meters, they won't measure amps in excess of like 250 milliamps, and that's a joke. And that's why they came to me free. I think they couldn't sell them. With which signal pattern is the RMS reading the same as the average reading? What is RMS? Anybody know?
Yes.
What?
Kind of. I know on a speaker, RMS is what it can always hold.
That refers the name of, that abbreviation, and I'm not going to call it an acronym because it's not a word. That abbreviation stands for root mean square. Root mean square. See?
I like power square.
Yeah. Root mean square. I'm not going to get too deeply into that. We're not actually, Alan Teal would be teaching that over in.
What's the answer?
Oh, I'm sorry. What you wanted was the answer on that. Number 24, B, sine wave.
I hate those.
What, sine waves?
Yeah.
Sine waves are not bad. They're not
Dumb.
Huh?
Math is dumb.
Oh, you love sine waves, huh?
No, it's dumb.
Not really. If you're, the reason you're saying they're dumb is you don't see a point in them. But when you're measuring, I'm on a meter and you're trying to find out what's wrong with somebody's Lincoln, you kind of see what's good for them. See, you probably would understand sine waves better because you did do it in math than somebody that had never studied that. So
I understand the sine waves because sine waves,
Stupid.
all the other ones, yeah.
Yeah. Yeah. Sine wave reminds me of the deer crossing sign. You know what I mean? People kept hitting deer down there about where they had the deer crossing sign, and somebody called the radio station. They moved that deer crossing sign somewhere else. We wouldn't have so many accidents.
What the hell?
Think about it. Okay. Which term is used to describe the resolution of a meter? The resolution of a meter?
What does that mean?
That means that how often it checks the reading. A digital oscilloscope checks the reading on this wire you're checking on. That meter only checks it every few seconds. That's the low resolution meter. If you got a high resolution meter, it instantly changes. I'm talking about like right away. You know how often a scope checks 20,000 times a second. A scope's checking it like a machine gun, just real super fast, or faster than that. Or like a Puff the Magic Dragon machine gun. With that 4,000 rounds a minute if it's set right. Okay. When selecting a meter, accuracy ratings that are, higher indicate more precise meters. Duh. That's a dumb question. Or is it? Let me think about this. Hold on a minute. When selecting a meter, accuracy ratings that are lower actually indicate more precise meters. That's a trick question. Seems like it'd be higher, doesn't it? And so a lower reading is going to be, When working on a hybrid vehicle, what type meter is recommended? You guys remember?
Yes.
Did the hybrid stuff? Huh? Which meter? Which one?
C.
Remember Cat 3 meter.
C, right?
Cat 3 meters, Yeah, or Cat 3 or Cat 4. Yeah.
25.
25 is the resolution of a meter is actually going to be, that's C, both A and B. Counts in digits. This digital multimeter is set to read ohms. The reading that is shown means what?
I guess. See.
It's reading the same thing if you got your lead swinging around in the air as it's reading here. What's that mean? That's an open circuit, right? Huh? Yeah, OL is an open circuit on an ohm meter or on a voltmeter. Typically, you'll see that on an ohm meter more than you will a voltmeter, though, because most of the time we got our voltmeter set at 20 volts, and we're reading a 12-volt system. On this meter, the reading converts to how many ohms? How many ohms is that meter reading?
3,124.
So yeah, because it's on kilo ohms, right? Yeah. Okay. 3,124. All right. Now, yeah.